Today you're going to talk about predicting products with double replacement reactions. The pages that you'll be working on through your workbook are 47 through 58. That is pretty much all the pages you need for this particular week of lessons. Today we're going to focus on pages 47, 54, 56, and 58. Your objectives are listed here. We're going to try to determine products based on the charges of the cations and anions and the polyatomic ions. So if you flip to page 47 in your workbook, you'll find this image here. And in this image, you'll discover that there are reactants over on the left, right? If we can recall from last semester, we have reactants on the left, and our products are what form on the right of our chemical equation. If you notice, sodium iodide, okay, its state of matter is listed here. It is aqueous, okay. Notice how you see an aqueous solution here, dissolved within water. And you got lead 2 nitrate, okay, in an aqueous solution as well. These are our reactants. And notice our products form and how we see that sodium has now bonded with nitrate and lead is now bonded with iodide, okay. And it's pretty simple to understand the pattern, but let's just give a quick review of what it means. So, there are a couple general rules when predicting products, and I like to color code to see, positive and negative. So my blue is positive for cations, positive, get it? Okay, and that's A and C in this example. Very similar to sodium here and lead 2 right here. And then I got B and D, which are my anions, which are negative. Okay, those can also be polyatomic ions. Do not forget that. So down here I have iodine, which is not a polyatomic ion, just a regular ion, quote unquote regular, okay, with a charge. And then I have nitrate here with a charge as well, right? Notice how my charges are listed over here too to help out based upon what products I would form over here. Now if you notice, lead does not have a subscript here, and does also not have a subscript here, but then iodine has a subscript here, but does not have a subscript here. Okay, it's important. All right, when you predict products, you have to know the charges of the original ions and how they would form a new chemical formula based upon those charges. So instead of going through examples in the workbook, which I'll do later, I want to show this short video, which will help you out. It's very quick and easy. Okay.
Two different reactions. Our first reaction will have balanced charges and the other will have unbalanced charges. Hello everyone, I'm Melissa Maribel, your personal tutor, and let's look at the trick for predicting products of double replacement reactions. Always start with...
Okay, if you notice, right, we have our metal, cation, metal, cation. We have our non-metal, polyatomic ion, also forms as an anion, and also another polyatomic, which is going to be an anion, okay? Positive, positive, negative, negative. Note how these subscripts here are not the same over here. That is on purpose.
With combining the inner elements together, where the positive charge, which is the metal, always goes first, and the negative charge, which is the non-metal or polyatomic ion, goes second. Note, this 2 subscript was only there to balance out aluminum and sulfate's charges. And this 3 subscript was only there to balance out calcium and phosphate's charges, so the 2 and 3 subscripts do not come down when we are predicting the product.
Okay, remember that. These subscripts here do not come down when we are predicting the product, okay? These subscripts are for this particular formula, not the new formulas over here.
Instead, we just look at the calcium and sulfate with their typical charges. Since the charges are the same, we do not have to add any additional subscript. So our first product is this. Now we'll combine the outer elements together, where again the positive charge goes first, then the negative charge. We will combine aluminum and phosphate together, and their charges are also the same, so this is our second product. And this is our overall unbalanced equation.
Okay, so that's an easy rundown of what it means. If you skip to page number 54 in your workbook, I made a couple highlights here. Again, here's the general formula of how to predict products. AB plus CD yields AD plus CB. Okay, just think of your A and your C as your cations, and your B and your D as your anions. And it asks you to predict the product of this particular reaction. Here are the reactants, here are the products. It gives you the steps of how to predict the products, right? Step 1, step 2, step 3, okay? That's pretty much showing you what this video just showed you. I want to skip down, though, to another page, okay? And go to page number 56. And notice how I've already started to write the charges above these particular cations and anions, so it helps me predict what's going to happen over here. Now, I'm not going to type it in, but I can say it out loud to you. We have aluminum, okay, iodide, which is bonding with, or I'm sorry, causing a chemical reaction with mercury 2 fluoride. If you remember from the video, mercury and iodine are going to bond together, okay, and aluminum and fluorine are going to bond together, okay. And mercury has a positive 2 charge, and iodine has a negative 1 charge, right? So I have an HgI2 is my formula, right? And aluminum is +3 here, and fluorine is -1, okay? So I have AlF3, okay? If you notice, crisscross applesauce. If you don't remember that, let me show you an example on this video as well.
All right, here's the trickier reaction. We will approach it the same way, where the inner elements combine and we place the positive charge first, then the negative charge. Again, note that this 2 subscript was only there to balance out calcium and chlorine's charges. And this 3 subscript was only there to balance out sodium and phosphate. So the 2 and 3 subscripts do not come down when we are predicting the product.
Remember, these subscripts are for these formulas, not these formulas.
Instead, we look at just the single elements of sodium and chlorine with their typical charges, which form our first product. Now we'll combine the outer elements together, where again, the positive charge goes first, then the negative charge. We will combine calcium and phosphate together, and their charges are not the same. Whenever your charges are not the same, you must put a subscript to balance out the charges. The charge of phosphate is now calcium's new subscript, and the charge of calcium is now phosphate's new subscript. So this is our product, and this is our overall
Ta-da! Okay, so she just showed you visually what I was explaining verbally to you about how we crisscross applesauce. All right. Hopefully, it gives you a better rundown of how to predict products. I highly recommend it doing this page on page 56. Okay, and email us with any questions. Thank you so much.